Okay, in this video, we're going to continue working with right angle trigonometry. Right angle trigonometry means that my triangle has a right angle. And then we can use our primary trigonometric ratios, which is another way of saying SOHCAHTOA. We're going to be using sine, cosine, and tangent. What does it mean? Today we're going to solve a triangle. So if I ask you to solve a triangle, it means you need to find everything about the triangle. So that means I need to know the measure of all three angles, and I need to know the lengths of all three sides. So in this triangle, we know three things. I know the lengths, I know two lengths, and I know one angle. This is obviously 90 degrees. I need to know the other three things. So before we get into solving it, I just want to introduce a way that we can label angles and sides of triangles. Angles are always going to be capital letters. I've got a capital X, a capital Y. Side lengths are always going to be lowercase letters. So for example, lowercase z. And the convention in mathematics is that we label the angle opposite the side as the corresponding letter. So little z is the side length across from capital letter Z. Similarly, big angle X is across from little side X, and then capital angle Y is across from small side Y. It's a convention in math that's going to help us stay organized. So I've got to find side Z. I've also got to find angle X and Y. So that's kind of our goal in this problem. We can kind of pick on actually what we want to do first. We do it in any order. I'm going to find angle X first. What that means is I'm going to treat angle X as my reference angle, and I'm going to label the three sides from the perspective of angle X. Doing a lot of different types of labeling here. So then I've got my opposite directly across, my hypotenuse is my longest side, and my adjacent. So from the perspective of angle X, if I want to solve for angle X, which trig ratio should I use? Well, I know opposite and adjacent, so we should be using tangent. So tangent of theta equals opposite over adjacent. So in this case, I want to find angle X, so X is theta, and that would be 15 over 8. Again, anytime we're using an angle, we need to use our inverse trig function. So to move tangent to the other side, I do the inverse of tangent. So I'm looking up this ratio in my calculator to figure out which angle it corresponds to. So I've got inverse tan, there's a lot of glare there, of 15 over 8. And then, as always, we're going to round angles to the nearest degree. So 61.9 would round up to 62 degrees. So I found one piece of information. I might as well add that to my diagram. I now know angle X. What's the quickest way to find angle Y? I suppose I could use trigonometry. I could label the three sides again from this perspective and do a similar procedure. However, it's easier to solve angle Y if you remember that all three angles in a triangle need to add up to 180 degrees. So I already know two of the angles, so it's very easy to find the third. It's just 180 degrees, that's the whole triangle. Subtract angle Z, which is 90, subtract angle X, which is 62. So Y must be 28 degrees. So if we know two of the angles in a triangle, I should be able to find the third by subtracting. I don't need to, and I shouldn't use trigonometry. It's very inefficient. And now there's only one more piece of information that I need to find to solve the triangle. I need to find side length Z. A couple of different ways to do this. I'm going to show two different methods. So here's our third piece of information that we need. Let's find lowercase z, which is a side length. We could use trigonometry. It's what we've been practicing so far this week. Again, looking from the perspective of angle X, if I want to find Z, the hypotenuse, I could use either the adjacent or the opposite. I actually know both of these. Why don't we use cosine? I'll just show you what I mean by that. If I use cosine, cosine is adjacent over hypotenuse. And this time I now know my reference angle is 62. I know my adjacent side is 8. And I don't know my hypotenuse, that's Z. So I can set up, and because I know 2 and want to find the third, we can cross multiply to solve. I also could have used sine. It wouldn't have made a difference. Sine is opposite of hypotenuse, and in this case, I knew the opposite as well. So sometimes you have choices about which method to use, especially as we come towards the end of solving a problem. Okay, let's solve by cross multiplying. I multiply the diagonal that doesn't include the z, so that's 8 times 1 is 8, and then divide it by the number left over, cos 62. So the length of z would be 8 divided by the cosine of 62. So z would equal 17.0, and the units are centimeters. So remember that we're rounding side lengths to usually 1 decimal place. I'm just going to add in another way to solve for z to show you that you have options and you have different kind of tools in your toolbox. This would be a method that you might have learned, or you should have learned hopefully in grade 7, 8, or 9, the Pythagorean theorem, which even before we knew anything about trigonometry, we knew that if I knew two sides of a right angle triangle, I could use Pythagoras to solve the third side. So we know that a squared plus b squared equals c squared. That's the Pythagorean theorem. A and b don't matter which one is which. Those are the two short sides, the two legs of our right angle triangle. C is the longest side of the hypotenuse. So in this case, we could say that, for example, a could be x, b could be y. Those could be reversed. C has to be the hypotenuse, so that would be z squared. So what is x? In this case, x is 15, y is 8, and I'm trying to solve for z. 15 squared, 15 times 15 is 225, plus 8 times 8 is 64. I could collect. And now to solve for z, well, z squared is 289. So to get z by itself, I can take the square root of both sides. Z is the square root of 289, which is 17. So you notice you get the same answer whether you use Pythagoras or trigonometry. So I'll just kind of circle that and say, you can pick the method sometimes on what to do. But the idea here is that we're solving triangles. It means I'm finding all three sides, all three angles, using this toolbox. So what we've added to our toolbox this week is trig ratios, sine, cosine, tangent. And then we're still using some of these tools that we would have learned in earlier math courses. All the angles in a triangle sum to 180 degrees. That's helpful. We also know the Pythagorean theorem, which could be helpful. So you've got different tools, different strategies to use, but our goal is always to find all the information. Sometimes it's nice to summarize it. So I now know that angle x is 62 degrees, angle y is 28 degrees, angle z, of course, is the right angle, so it's 90. And I also know my three side lengths, so they're lowercase. 8 was 15 centimeters, lowercase y was 8 centimeters, and then we finally learned that z was 17 centimeters. So it can be nice to write a little therefore statement, just concluding or summarizing all the information that we've found in the problem. So when I say solve the triangle, again, I would start by sketching and labeling. Then I want you to find all three sides, all three angles. And often there's different paths or different routes to get there. So let me know if you have any questions. And otherwise, thanks again for watching my video.